For years, when we talked industrial steam, we talked about one thing, the burner. But that's all changing. Today, we're here to talk about a fundamental shift in plant technology, a move toward electrification that redefines not just efficiency, but safety too.
And when I say changing, I don't just mean a minor improvement. This isn't some small tweak. We're talking about a complete shift in how we generate steam, and it's all being driven by electrification.
So we're moving beyond the burner, and what we're moving to are electric boilers and these really smart hybrid systems. This means steam that's cleaner, delivered a whole lot faster, and gives plants a level of flexibility they've never had before.
All right, let's get into the nuts and bolts. To really understand the opportunity here, we first need to define the core technologies that are making all this possible.
Essentially, you've got two main types. First, electrode boilers. They work by passing an electric current directly through the water, using the water's own resistance to make heat. Then you have resistance boilers, which, well, they work more like a giant kettle, using heating elements. Either way, you're converting electricity directly into high-quality steam. And this brings us to the really clever part, the hybrid strategy. Now, the key here is integration, not replacement. A hybrid boiler house intelligently combines the fuel boilers you already have with a new electric one, so you get the best of both worlds, right? You keep your redundancy and you get that clean, flexible steam. So why is this becoming the new standard? You might be wondering that. Well, the reasons are practical, they're powerful, and frankly, they address the biggest challenges the industry is facing today.
It really boils down to three main drivers. First, decarbonization, because you can finally tap into renewable electricity. Second, you get incredible speed and control to match steam demand in an instant. And third is that smart hybrid strategy, which makes the whole transition manageable and cost-effective.
Now, for the core of this briefing, as inspectors, we absolutely have to know how to approach this technology. So, here's a 5-point checklist that covers engineering and safety compliance.
Our first checkpoint
is all about the physical system itself, the pressure bounder.
Now, here's the crucial point. Despite the new heat source, it is still a pressure vessel. That means all the fundamental principles of integrity management and relief protection that we know so well, they still apply. We're starting on familiar ground here.
Checkpoint 2. This one's about what's going inside the boiler.
The water.
And this is where we see a major difference. With electrode boilers, water quality isn't just important, it becomes mission critical. The system's performance and its safety depend directly on the water's conductivity. That makes disciplined treatment absolutely essential. There's no cutting corners here.
All right, checkpoint 3 covers the new hazard,
The ones that come along with this new energy source.
Let's be clear, we're introducing high-voltage electricity into the boiler house. This brings new risks, everything from insulation and earthing to the potential for a dangerous arc flash. Safety is no longer just a mechanical concern. It demands tight coordination between your electrical and mechanical compliance teams. Checkpoint 4 is about the brains of the operation.
The boiler management system.
You see, in a hybrid system, the control logic, the program that manages all the interlocks and trips, it becomes a whole lot more complex. It's not just running things for efficiency anymore, it's a critical safety barrier that prevents unsafe conditions between the different systems. And our final checkpoint, number 5, is all about the data
and how we use it to prove the system is operating safely over time.
The old paper logbook is being replaced. Digital logs that track every single start, stop, trip, and change in water conductivity. That is now the key data for integrity management. This gives us a level of traceability and solid evidence that we've just never had before.
So how does this actually look in a real facility? Well, the path forward is incremental. You can start small. Identify a stable steam demand, add an electric boiler to handle part of that load, and just keep your existing system as a backup. The key is, if you prioritize solid controls and water treatment from day one, you've got a fast, low-risk path to modernization. The takeaway is clear. This isn't an upgrade that just gives you one benefit. It's a comprehensive improvement across the board to your control, your emissions, and your reliability. It really is a clear, secure pathway to the future of industrial steam. This technology isn't just theory. It's here, and it's being deployed right now. So the only question that really remains is your facility prepared for the shift?